Hello, good evening. Can you hear me? Yeah. Okay, great. So we'll just wait like 2 or 3 minutes so that if people want to join, they can. Okay. And let me also know whether you can see my screen or not. Okay. Yeah. So can you see my screen? It's in the presentation mode, right? Cool. Okay. I guess we can start. Yeah. So welcome to this bioelectrochemistry course for 2025. This is basically a very, very, very preliminary introduction to the bioelectrochemistry, which will help you guys in understanding what exactly biochemistry is, or uh, say the fundamentals which is required to understand this field. What are the things associated in this? I hope everyone has completed their week 1 lectures so that this discussion will be helpful. So, for all of you guys who have not done any NPTEL course earlier, so the basic protocol and the basic thing goes like, so every week, whenever you enroll into a new course, so every week there will be problem solving sessions. So these problem solving sessions are aimed at solving questions which are similar to the ones which you are getting in your weekly assignment. Okay. They are not the exact same questions, but definitely they will depend upon the questions which we gonna discuss. As this has no dedicated format that, oh, we need to cover this much and that much and all that. So it's a feedback system how this discussion hours work. So if you guys are interested and if you guys are facing some troubles or some issues in certain topics, you can either tell me in advance, like before the discussion hour happens, which will be happening in every Saturday, like 4 to 6 p.m. Okay. So either you can send me before that, oh, that in this particular week, this was a topic which I want to understand in more depth, or I was not able to follow the lectures or something like this. Okay. There is no structure to how we can conduct this discussion hours. It can completely go according to you guys if you want to know something about, or if you want to understand that, oh, even this basic concept, I'm not able to understand, not able to grasp. Hence, I cannot move forward with my lectures. Okay. So, this is how these sessions can go. This is how I personally take these sessions. Every student who is taking NPTEL discussion hours have their own way of doing things. So, how I do basically is I try to uh, cover some of the things which have already been discussed in that week's lecture by the course instructor. Okay. And then we try to solve some questions. And while we are solving some questions, we'll dwell into the basics of those questions and the information which we can take from those questions. Hence, we are learning, we are revising whatever we have learned in that particular week. And then we are forwarding with solving questions so that those questions can help us understand the concepts which we have just learned. Okay, so basically, it will be divided into the lecture will be like 1.5 hour. Like it will be definitely be for more than 1.5 hours, but it is not necessary that it can go the way which I have told you just now. Okay, this is the way which works best for me. But as these sessions are designed for you guys, if you find it difficult to follow, or if you are having trouble, ki, oh, I'm not okay with this structure, how you are taking this discussion hour, we can obviously take the feedback. We can get into the depth of how you guys can better understand the concepts, and hence we can move forward accordingly. So it completely depends upon your feedback. So I will provide you my email ID by this week, or even when I'll be posting these lectures, on YouTube, I'll put in the description my email ID. So you guys can always approach me and give me some feedbacks ki, oh, this is how we want to proceed with this particular lecture. So you guys might have already gone through the uh, like course outline, right? So if we go to the course outline, let's see. Uh, yeah, so this is the, can you guys just confirm whether you can see my this course enrollment page of bioelectrochemistry? Cool. So, sorry, so this is the intro page, right? Which you guys have, if you have gone into the week's session, you might be able to see. Okay, so if you see, that's an elective type of course. It is predominantly for undergrads for whom all these concepts will be very new, and they are learning the basics of chemistry, like electricity and all that, and how both of them can give an amalgamation of a interdisciplinary field called bioelectrochemistry. And it's for postgraduates who are looking to work into this field and they just want to brush up their fundamentals. So as I already mentioned, that it's a very short course. It's a like 4 week course only. So around 40 lectures, I guess, will be there. For 20 or 40 lectures will be there. Okay. So the week one, which I really, really hope that you guys have completed or at least gone through the video once, because then only these lecture hours will be helpful. Okay, so the week one was comprised of fundamentals of electrochemistry with special reference to bioelectrochemistry. The following week, for which the lectures have already been released, will focus on electrodes and potentiometry. The next week, the last second week of this course will focus more on redox titrations. And the last week of this course will summarize this course by introducing you guys with the concepts of to the concepts of electroanalytical techniques. Okay, so all these are basic informations which you have already uh, like gone through. So let's start with this course. And as I can see, few of you are here already. Would you like to like introduce yourself. Let's see from where you are, what you guys are doing, and why specifically you opted for this course, and what are your expectations of out of this course. If you're free, feel free to like just unmute yourself and chat. Anyone? Yeah. Hi. Okay. Okay. Acha. Okay. From which? Yeah. Sahastra. Acha, acha. Okay, great. So, how is your, so you are pretty new to the academic field. How is the engineering treating you? It's going well till now? Okay, okay, great. So this course you are taking as an like additional credit, or is there some prerequisite for you guys to have NPTEL courses in your curriculum? Okay. Hmm, hmm, hmm. Okay, so why bioelectrochemistry? Because I can understand you are a predominant chemical engineering guy, right? Okay, 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 okay. Okay, no problem. So it's good to hear. So let's start with today's session. So basically, if you guys have went through the lectures, and I will really advise you to do that whenever you come for the discussion hours. Otherwise, they won't be useful at all. It will be like wasting time for you as well as for me, because most of the time I base my lectures completely on how that particular week's lecture, like the things which have been covered in that particular week. Okay, so obviously, as we are starting the course, we'll introduce the term. So, what is bioelectrochemistry? So, it doesn't need any genius to understand like what bioelectrochemistry is. Even if you don't understand what exactly it is, but you can always break the terminology and you can understand that some of these things will be playing role in this field. Okay, so if you break down the term, it has bio, electro, and then chemistry. Okay, so bio is obviously it's coming from the biology side of it. Electro is coming from the electricity aspect of the bioelectrochemistry, and chemistry is definitely the full chemistry aspect of it. So, how we are using the things which we can do by chemistry to generate electricity, use electricity, measure electricity, XYZ things. Okay. Secondary, what we can do when we are using electricity, how to change the chemistry of a thing, or how to start the chemistry in something by using the electricity. Bio, because biology is a like field of studying living organisms. Living organisms undergo lot of biochemical reactions, biochemistry, right? If you have heard of it. So if those reactions are going on, reactions at the end of the day are the chemistry aspect of the biology. Okay, and if a reaction is going on, there is definitely association of some ions, right? It can be protons, it can be neutrons, correct? So the moment you have reactions, so a living system is undergoing chemical reactions, right? Biochemistry aspect of it. And if a reaction is going on, then the charge is always associated with the reaction. And the moment we talk about charge, we can always introduce the field of electricity whenever the charge is, because of what electricity is, the current is, the flow of electron or flow of the charged ions. Okay. So bioelectrochemistry is an interdisciplinary field that combines principles of biology and electrochemistry to study the interactions between electrical processes and biological systems. It focuses on understanding how biological molecules, cells, and tissues interact with electrical signals or undergo electrochemical reactions. This field has significant applications in medicine, biotechnology, and environmental sciences. So, medicine, um Let me give you a brief of how bioelectrochemistry is like finding its application in medicine. So whenever you take a medicine, a small capsule or a tablet or whatever, right, it will go inside you. It will face certain type of environment in the stomach for say. Stomach has a pre-known, predefined high acidic pH associated with it. So the moment we say about acidic pH, it means there is excess of hydrogen ions, excess of plus, right? Acidity is associated with it. So if a molecule is entering inside you, it will be affected by how it is encountering into that surrounding. Hence, medicine to the delivery of medicine, the interaction of medicine, how the medicine is going to affect your body will depend upon its bioelectrochemical properties. Okay. Biotechnology is basically engineering the biology. So in future we'll see that there are certain like in green chemistry also and in biotechnology we use the information, the knowledge of electrochemistry to come up with devices, to come up with sensors which help us in either detecting or diagnosing some biology or the living being. Even either it can be outside your body or it can be used for inside, like for the inside of your body. Okay. And then the environmental sciences. So if we want to check whether that particular soil is having a suitable conditions even to grow a crop, or whether that wood, for example, is suitable for utilizing it for like some other sources or other information or other things which we can do out of it. All these fields are interconnected. So the moment we study about bioelectrochemistry, it will find its way wherever the living beings are there. Either it can be human being, microorganisms, massive organisms, plants. Every single thing will be affected by the bioelectrochemistry of it or the foreign object which we are introducing. So the key areas in which biochemistry is used or helpful or is like found its roots belongs to electron transparent biological system. As I'm assuming that if you guys have not studied like PCB in your in your 12th examinations, you guys at least heard of electron transfer chain, right? Or ETS, electron transport system. So all these things, at the end of the day, why we are breathing, why we are eating food, so that we can get the energy. How this energy is being formed in a living being is via system of proteins which are present in the membrane, in which the electron basically transports. So when electron is traveling through these proteins, it is giving its energy out. That energy is used for oxidation of the food or for taking out the energy which is stored in the food. How the energy is stored in the food? In the form of chemical bonds at the end of the day, right? Hence, if we are eating something, the end product of it is breaking of those complex molecules into simpler ones so that we can extract the energy. How we are extracting the energy is through a chain of proteins through which the electron basically travels. When electron is traveling, it will release its energy, and that energy can be used to break these bonds. Hence, in biological system, electron transport chain is very important aspect in which bioelectrochemistry is very useful. So studies redox reaction in enzymes, proteins, and other biomolecules. Explores the role of electron transfer in processes like photosynthesis, respiration, and metabolism. Biosensors, as I was talking about earlier. So the bioelectrochemistry develops devices that uses biological molecules such as enzymes, antibodies, DNA to detect specific substances such as glucose and diabetic monitoring. This is one example of a biosensor. So how a biosensor works? Biosensor, as the name suggests, that it's a sensor which is sensing something live. It's a either some biological component is associated with this sensor. There are different types of sensors, but not all sensors are biological sensor or biosensors. Okay. And last but not the least, electrochemical techniques. So using techniques like voltammetry, amperometry, and impedance spectroscopy to study biological systems. So why we are talking about bioelectrochemistry only in the fields of bio? Because with the electrochemistry aspect, there is biology also associated. So we'll study all the principles of electricity and chemistry with respect to biology. Okay. Then bioelectronics. So it involves interfacing electronic devices with biological systems such as neural implants or pacemakers. You guys have hearing these terms a lot nowadays, right? The neural implants, which Elon Musk team is has already developed, and the pacemakers. Pacemakers are basically they are like age-old devices which are placed in your heart in people who have some abnormal heartbeat and they might be at a risk of heart attack. Okay. Then electrochemical energy conversion. So examines how biological systems can produce or store energy like in biofuel cells. We'll talk about this is just the introduction of where these can be explored. So we won't focus on every aspect because then it will take a lot of time. This is just an introductory part that if you want to learn bioelectrochemistry, these are the areas in which already bioelectrochemistry is providing a significant input in improving these sectors of technology. Okay. Electroporation. So it studies, basically it studies how electric fields can be used to increase cell membrane permeability, aiding in drug delivery or DNA transfection. So all these terminologies might be very, very, very heavy for some of you guys who might not be from the biology background. So let me break one term at a time. Electroporation. So if you break this term, it basically gives you two part, right? Electro and poration. Electro again means like electron, electricity, all this. Poration, as the name suggests, it means pore formation, making a pore or a hole or permeability association with the poration. Okay, so electroporation, it basically how we can use the electricity. What is electricity? Electricity at the end of the day is the flow of electrons, right? And I told you that living beings, when they are undergoing chemical reactions, they are using or generating electrons. So our system is already having electricity and the electrons associated with it. The moment you introduce a foreign, the electricity from the outside, the systems will behave differently. Some changes will be there, right? So we use this property of electricity of electron that is present in our cells, as well as we can use electricity from the outside to make a cell membrane. A cell is bound with a membrane, right? So a cell having a membrane, it is not permeable because the reason why a cell has to have a membrane is first to maintain the size. The second is to save it from the outside world, right? If we don't have a envelope to protect our things like our nucleus, like our ribosomes, like our small organelles which are present in the cell, then we won't go towards the organization because we are complex organisms, right? Organisms are made up of organ systems. Organ systems are made up of organs. Organs are made up of tissues. Tissues are made up of cells. Okay. So if we don't have a membrane, we cannot go move towards from single cell entity to a complex functioning organism. Okay, so that is why if we want to introduce something from outside from like outside inside to inside the cell, it is difficult because this is how our system is made up of. But with the help of electricity, because the moment we disturb the charge permeability of a cell membrane, it will lose its inherent strength or the structure, right? So the moment it becomes little bit weak by introducing a current from the outside, whatever we want to introduce inside the cell, it will be easier for the cell to take it up. Okay. Then, and what is that foreign subject? Mostly it will be a drug or a small molecule for aiding something or helping in something. Okay. Then we have bioelectrochemical systems for environmental applications. These were the key areas where bioelectrochemistry is actively being used. What are the applications of bioelectrochemistry? So in medical diagnostics, For example, glucose sensors. Right now, you might be hearing a lot about continuous glucose monitoring, right? So, people who are at a higher risk of or are suffering from diabetes, they have a system or a chip injected underneath their skin, which will continuously detect their glucose level in the blood. And the moment that glucose is not sufficient for that person's like standard maintenance, it will alert the individual, and hence the individual can take their own like either a prescribed drug or a meal. It completely depends upon it. Okay, upon them, sorry. And then electrochemical DNA detection, again, it's a completely related to biology. We might not go into like too deep into it, but yeah, these are the applications. Therapeutics, so basically development of neural prosthetics, cardiac pacemakers, and drug delivery systems. Energy production for biofuel cells, basically for renewable energy, which we are like actively working and using the knowledge of bioelectrochemistry. Then environmental sciences, monitoring and treating pollutants through bioelectrochemical systems. So this field basically bridges the fundamental researches in biology, obviously, and the practical applications of engineering in medicine, m- especially using the principles and basic phenomena which are prevalent in electricity and chemistry. Okay. Now, another key aspect or the key point which we should know before understanding the bioelectrochemistry is the chemistry part of it. Okay, so in chemistry, whenever I'm saying that there is a reaction term associated with it, we are saying that if something is being sensed, it is the electron, but from where those electrons are coming, from where, and if they are coming, then why they are not getting accumulated? Is there something which is accepting them? Right, so all these questions arises. So as it's not for a undergrad like basic like 11th 12th standard course, I'm assuming that all of you know from the like the very basics of redox reaction, because they will form the understanding of our galvanic cells and the basic fuel cells and all those things. Okay, so a redox reaction, which is basically short for reduction oxidation reaction, is a chemical reaction in which electrons are transferred between two substances, leading to changes in their oxidation states. It involves two simultaneous processes, as the name suggests, right? Reduction and oxidation. So, oxidation basically means the loss of electron by a substance, increasing its oxidation state. Reduction means the gain of the electron by a substance, meaning decreasing its oxidation state. Okay, some of the key features of redox reactions are electron transfer, coupled processes, and change in the oxidation state. So, electron transfers are transformed from the species undergoing oxidation to the species undergoing reduction. Coupled processes means oxidation and reduction occurs together, because if something is releasing an electron, there has to be a counterpart of it which will receive an electron. Okay, so if one species is oxidized, another must be reduced. Changes in oxidation state. So the oxidation state of a species changes as a result of the reaction. That is why there will be a net flow of electron. Flow of electron means electricity. But why a substance or an atom should release an electron, or the other species should gain an electron, right? So the basics of this will lie in the stability of that particular atom, or the potential energy that particular atom has, right? Or the potential difference of these two different species which are interacting simultaneously with each other, where one is releasing an electron and the other is receiving that particular electron. Okay, so some of the examples of redox reaction, as mentioned earlier, the redox reaction will have two parts: the reduction reaction and the oxidation reaction. In oxidation reaction, the electron will be released, and in the this your reduction reaction, the electron will be received. So simple reaction, this is the net reaction, you can see that zinc, oh, okay, so this counterpart is missing. Sorry for this, I'll add when I'll be giving you the slides. So the oxidized part will be, so it was zinc, now it is Zn plus 2, which means zinc oxidized itself, right? So it has released an electron. So if this has released an electron, so it will, the electrons which zinc has released, some other species will receive it. That other species or the atom will gain that electron. So the gaining of electron is called reduction. Okay, so Zn here will act as an reducing agent because it is reducing the reducing another species. Copper, on the other hand, is receiving that electron. It itself is getting reduced. If it itself getting reduced, meaning it has received electron from outside, indicating that it has oxidized the other species. Hence, it will be an oxidation agent, oxidizing agent. Okay, so simple reactions, then combustion, these are some standard reactions. Okay, then the application of redox reactions. So again, whatever the application of bioelectrochemistry, because it depends, the core, the strength of the bioelectrochemistry is in the chemistry and the electricity aspect of it. And the chemistry relies in the redox reactions. Hence, wherever the bioelectrochemistry are used, they are, at the end of the day, they are using the redox reactions only. Okay, so applications of redox reactions include energy production, metabolism, corrosion and protection, and environmental chemistry. Again, saying these are not the only applications, they are the some of the applications which have simplified so that they can cover majority of it. Okay, let me okay, let's go and understand little bit more about redox reaction, as it is the basic of uh, all this. And you guys have to tell me whether you can listen to the audio of this particular video. Okay, can you guys hear? It's not audible. Okay, then I have to make certain changes in the sharing setting. Okay, anyone of you can help me out? How sorry for the disturbance. Yeah, I guess now you guys can see my screen, and we'll check with the audio. So let's just have a view of this. Okay.
In today's video, we're going to take a look at redox reactions, which are reactions in which oxidation and reduction both take place at the same time. And to do this, we'll cover displacement reactions, ionic equations, and half equations. We saw in a previous video that one meaning of oxidation is the gaining of oxygen, and that reduction is the loss of oxygen. For example, if aluminium reacts with oxygen to form aluminium oxide, we can say it's been oxidized. Whereas if we take away that oxygen, then it's been reduced. The terms oxidation and reduction can also refer to the loss and gain of electrons though. And instead of just remembering which is which, most people use the mnemonic OIL rig, which stands for oxidation is loss, reduction is gain, and this refers to electrons. So if we had a magnesium atom, and it loses 2 electrons to become a 2+ ion, then it's been oxidized. And if it gained those 2 electrons back, then it would have been reduced. Most of the time though, these oxidation and reduction reactions don't happen by themselves. Instead, they both take place at the same time. Because if one substance loses electrons, then another substance has to gain them. And because both happen together, we call them redox reactions, which just means reduction-oxidation reactions. For example, if we react some magnesium with a dilute acid, which we can represent as H+, because that's the important part of an acid, then the magnesium atoms will lose 2 electrons and be oxidized, forming magnesium 2+ ions. Meanwhile, the hydrogen ions will gain those electrons and so be reduced to neutral hydrogen atoms in the form of hydrogen gas. Another place we see redox reactions is in displacement reactions, which involve a more reactive metal displacing a less reactive one. For example, if we look at our reactivity series, we can see that calcium is more reactive than iron. So if we added some calcium to a solution of iron sulfate, then the calcium would displace the iron to form calcium sulfate, while the iron would precipitate out as a solid. For reactions like this, it's sometimes useful to write them as ionic equations, in which we only show the particles that actually take place in the reaction and change in some way. For example, if we showed everything here as ions, we can see that the sulfate ions stay as SO4 2- ions. They don't actually change or take place in the reaction by exchanging electrons. Because of this, we call them spectator ions and get rid of them from our equation. And what we have left is the ionic equation. We can actually break this down even further though, by writing individual half equations which show the gain and loss of electrons for each of the elements involved. To do this, we first copy the ionic equation, but only for one particular element. So for calcium, we would write that a neutral calcium atom goes to form a calcium 2+ ion. Next, we need to add our electrons to make the charges balance. As the calcium atom loses 2 electrons, we can think of the calcium ion as one product, and the 2 electrons as another product. So we put plus 2 electrons on the right-hand side. Then for iron, we show the iron 2+ ion going to form an iron atom, and then again think about our electrons. This time the iron ion gains 2 electrons, so we place the 2 electrons on the left, because they have to combine with the iron ion. Whenever you do these half equations, just check that the overall charge on each side balances. For example, in our iron half equation, we can see that on the left we have a 2+ charge and 2 1- charges, which add together to make 0. And on the right, everything is neutral, so also 0. If you ever find that the overall charges on each side aren't the same, then you've probably put your electrons on the wrong side. Anyway, that's all for this video. So if you enjoyed it, then
So, right, we got this zest that redox reactions are always coupled, correct? If there is a reduction, then there will be oxidation. What is reduction? That is loss of electron. What is oxidation? That is gain of an electron. Okay. Then this process, redox, it gave rise to the cells and batteries because it is spontaneous. The release of an electron and acceptance of the electron, that is basically electricity, right? The flow of electron is called electricity. So we use this phenomena to come up with the cell, which is called a galvanic cell. So what is a galvanic cell? A galvanic cell, also called a voltaic cell, is an electrochemical cell that generates electrical energy through a spontaneous redox reaction. It consists of two half cells connected by a salt bridge or porous membrane and an external circuit that allows electrons to flow. The key components of galvanic cells are: first, it's a two electrode system, meaning there's anode where the oxidation will occur, that is loss of electron, a cathode where the reduction occurs or the gain of electrons. Then electrolytic solution. Let me take this. Yeah, electrolytic solution, that is each half cell contains an electrolyte that provides ions for the redox reaction. Salt bridge or porous barrier. It maintains electrical neutrality by allowing ion exchange between the two half cells
preventing charge buildup, and an external circuit which connects the electrodes, allowing electrons to flow from the anode to the cathode. This is how a galvanic cell will work. So what the galvanic cell has, it has two electrodes, anode and cathode. So at anode, the oxidation will take place. What is oxidation? So a metal or species or the electrode itself will lose an electron. For it forms cations that enters the solution. Okay. Then the other electrode was cathode, correct? And what happens at cathode is the reduction. So electrons travel through the external circuit to the cathode, where they combine with cations from the solution. Electron flow, that is electrons flow from the anode, that is negative electrode, to the cathode, that is the positive electrode, through the external circuit. Ion flow via the salt bridge. Anions migrate towards the anode and cations migrate towards the cathode to maintain the charge balance. This is an example of a very simple zinc copper galvanic cell. So this is the overall reaction. So zinc is being oxidized, as you can see, and copper is reduced, as you can see here. Okay. Now what are the characteristics of galvanic cell? The characteristics of galvanic cells are electromotive force. What is electromotive force? The voltage produced by the cell determined by the difference in reduction potentials of the two half cells. So this is pretty understood, right? So if electron have to flow from anode to cathode, this difference will generate the flow rate. Okay. So more the difference between the anodic material and the cathodic material, more electricity or more flow of electron will be there, and this difference is called electromotive force. Okay. Spontaneous reaction. So the cell operates spontaneously because the overall reaction has a negative, gives free energy. Okay. What are the applications of galvanic cell? So galvanic cells are the basis for batteries such as alkaline batteries, lead acid batteries, and lithium ion batteries. So whatever we use today, all the devices, they come up with batteries, right? So the basic principle of every single battery, ion battery, right now we are majorly lithium ion batteries, correct? In your phones you use lithium ion batteries. So majorly the principle remains the same, it's just the components change. The basic component will also be the same, just the material of those components will change. So let's see how a galvanic cell works and what exactly is a galvanic cell. Okay, 1 minute, I'll share. Yes.
The galvanic or voltaic cell is the most easy and fundamental cell to understand. Let's take a look at this animation to see how this cell produces a voltage and current flow. It all starts with two materials, zinc atom and copper ion. The zinc atom always wants to lose 2 electrons. Only when it loses 2 electrons does the zinc atom become stable. However, in order to achieve stability, the copper ion wants to accept 2 electrons. Therefore, if we connect them together through a conducting cable, there will be 2 electrons flowing through them. If we can produce more such zinc atoms and copper ions in a sustainable way, then we will be able to achieve a continuous flow of current through the connecting cable. Let's see how we can achieve this. To produce copper ions and zinc atoms sustainably, let's use a copper sulfate solution, which is composed of numerous copper ions and a zinc metal bar, which, as the name implies, contains a lot of zinc atoms. The copper ions in the solution are starving for electrons. If we connect the solution and the metal bar together, then the zinc atoms in the bar will want to donate their electrons. But after donating, the zinc is transformed into ions, and ions cannot stay in a metal. So we'll have to introduce another aqueous solution around the zinc metal bar to accommodate these new zinc ions. Now the electrons flow through the circuit, generating electricity, and the copper ions receive them. Once received, the copper ions become atoms. To accommodate these new atoms, we need a copper metal bar. This unique arrangement will produce a voltage and electron flow. However, there is an issue. You might have noticed that in the course of this process, positive charges are accumulated on the left side and negative charges are accumulated on the right side. As these charges build up, they block the journey of electrons. Here you can clearly see how the built-up charges impede electron flow. Therefore, proper measures must be undertaken to ensure that the electron flow is continuous. A simple solution for this is a salt bridge. The salt bridge is an aqueous solution with a lot of Na+ and Ci- ions inside it. This bridge is blocked at both ends with cotton material. However, this cotton material is capable of conducting the Na+ and Ci- ions. If the charge outside of the salt bridge is positive, then negative ions will get out, and vice versa. What exactly happens when the salt bridge is introduced in between the chambers? The excess positive charges on the left side will obviously attract the negative ions inside the salt bridge. These ions will leak out and neutralize that region. The exact opposite process will happen on the right side, and there also the accumulated charges will get neutralized. In short, the introduction of the salt bridge made the voltage and electricity production sustainable. The cell we have just created is known as a galvanic or voltaic cell. You can observe that over time, the zinc metal bar erodes as it loses zinc ions, becoming thinner and thinner. The exact opposite happens on the copper plate side, which becomes thicker. The galvanic cell will continue its operation until the zinc is completely depleted or the ions in the salt bridge have been completely exhausted. We hope you have enjoyed this video and that it gave you a clearer understanding of what a voltaic cell.
Correct. So this indicates how simple the cell is, and 1 minute, let me share the screen. Yeah, how simple the cell is, correct, and how it works basically. So there is a solution, there are electrodes, and the flow of electron is maintained, and to make sure that it always keep flowing, we have electrolytic solution, and we need to like select the electrodes in such a way that there is a voltage difference between these electrodes so that the force or the electricity can be generated. Okay, with this brief introduction of the topic, that is bioelectrochemistry and the major components which are discussed in the first week, we'll now discuss some of the assignment questions or the previous year questions which might help you guys in solving your current year assignment. Okay, so the general rule is, for the easy questions I give like 30-second or 45-second for you to answer in the chat box, or you can unmute also and give me the response. For little bit difficult question or lengthy question, I give 1 minute for you guys to answer. Okay, and I'll tell you when your time starts and when it ends. So feel free to chat in the chat box and give your answers. Even if it is wrong, feel free to give your answer. Okay, so here it goes. So the first question says, chemical and electrical phenomena are often associated, as in the case of redox reactions, when electrons are emitted and absorbed. In 1922, Planck discovered a method for analyzing the occurrence and content of various substances in solutions using electrical measurements. The solution is analyzed with two electrodes, one of which is a dropping mercury electrode. At a voltage specific for different substances, redox reaction causes the current to rapidly increase to a level dependent on the concentration of the substance. So what is the name of this researcher? So I'll give you guys, I guess, 30 seconds for this, because this is a pretty theoretical question that if you know, you know, and if you don't, then obviously we'll know by the end of this question discussion. But still, I'll give you guys 30 seconds and your time starts now. to attempt it in the chat box. Sorry for that. Yeah, so your time stops now. The 30 seconds are over. So we'll see how many of you attempted. Oh, okay, no worry. So the correct answer is Jeroslav Herovaski. I don't know whether I'm pronouncing it right, but yeah, this is a very general information question, so no need to worry if you don't know the answer to this question. Okay, so what basically this person did and what this phenomena is, it is called polarography. So an electrochemical method used to analyze substances in solutions. It involves measuring the current that flows through a solution as a function of an applied voltage. The setup uses two electrodes, a dropping mercury electrode, it serves as the working electrode, and a reference electrode, which basically maintains a stable potential. As the voltage changes, different substances in the solution undergo redox reactions at specific potentials, leading to measurable changes in the current. These current changes are proportional to the concentration of the analyte, allowing for quantitative and qualitative analysis. This groundbreaking work was awarded a Nobel Prize in 1959. Okay, coming to the next question, it says, with atomic number blank, lithium is the lightest metal with a density of 0.53 gram per centimeter cube. I'll give you guys 1 minute for this question, because if you don't know, you can go back to your chemistry 101 and try to recall it. And your time starts now. Put your answers in the chat box and remember what the question is asking, and what is the atomic number of lithium, which is the lightest metal. And why we want to know about lithium? Because it is used in batteries, lithium ion batteries, right? So there must be some reason why we are using lithium in the batteries, correct? So one of the reason is that it is one of the lightest metal. And why it is lightest? Which means it should fall at the extreme left of the periodic table, because all the metals are there, right? Alkali metals, alkali earth metals. So what is the atomic number of lithium? It's a okay, your time stops now. It's a no-brainer. Lithium atomic number is 3. As you can see in the periodic table, that here is the lithium. This is the first metal, right? This is the first metal. It has atomic number 3 with density 0.5 gram per centimeter cube. So you know that this first one is the alkali earth metal, correct? Then this is I guess alkali earth metals. Then this purple one is the transition metals in between. This green one is the post transition metals. This brown one is the metalloids, if I'm correct, or actinides, I guess, correct? So this is the basic periodic table, and even if you don't remember whole of it, just remember basic qualities of metals, like what is the quality of a metal, what is the quality of alkali earth metal, about carbon, halogens, all those like basic qualities. You don't necessarily need to remember the whole periodic table. Okay, coming to the next question, the value, I really hope that all of you guys should answer this question. So what is the value of Avogadro's constant? Is it 6022140076 into 10 per 23 per mole, or is it 60.22140076 10 per 23 per mole, or is it 6022.14076 into 10 to the power 23 per mole, or is it 6.0221407 into 10 to the power 23 per mole? I'll give you guys 1 minute for this particular question. Feel free to drop your answers in the chat box, and your time starts now. Try to answer this question. Okay, your time stops now, it ends now. So what is the right answer? The right answer is 6.022 into 10 to the power 23 per mole. This is the Avogadro's constant. So what exactly is Avogadro's number? Avogadro number, oftenly denoted as N subscript A, is the number of constituent particles. It can be either an atom, molecules, or ions in 1 mole of a substance. It is a fundamental constant in chemistry and has the value of 6.022 into 10 to the power 23. This means that 1 mole of any substance will contain 6.022 into 10 to the power 23 entities. So if a molecule is 1 mole, it will have this number of molecules. Okay. So some key points about Avogadro's number is that the basic, this is general information because it might come handy sometime, you never know. Okay. So so it is named after the Italian scientist Avogadro, who proposed in 1811 that equal volumes of gases under the same temperature and pressure, that is standard condition, contain an equal number of particles. What is the relation of a mole with Avogadro number? So a mole is a standard unit in chemistry that represents a fixed quantity of a particle, right? We are all well aware of it. For example, 1 mole of hydrogen atom contains 6.022 into 10 to the power 23 atoms. Okay. Similarly, 1 mole of water will contain 6.022 into 10 to the power 23 atoms, molecules. Okay. So what are the applications of Avogadro number? It is used to convert between macroscopic scales, that is grams, liters, and the microscopic scale such as atoms and molecules. Correct? Then only we can relate. So 1 kg, what it means with respect to the atoms or molecules. For example, 1 mole of carbon weighs exactly 12 grams and it contains 6.022 into 10 to the power 23 atoms. Okay, how we are relating macroscopic scales, that is grams, to atoms and molecules. Okay, what is its significance? It basically links measurable quantities of substances with the number of particles, allowing chemists to balance chemical equations and calculate reaction yields. Okay. So the next question for today is delta G is equal to NFE. Okay, where delta G is a change in free energy, N is the number of moles, F is the Faraday's constant. So what is E? If you guys have seen this week's lecture, you should answer this immediately, but still I'll give you guys 1 minute to answer this question. So what is E in the equation of delta G is equals to NFE? Whether it is electron charge, current, voltage, or charge density. And your time starts now. Feel free to give your answer in the chat box, and I'll highly suggest to go through the lectures as they are published, because every week all the lectures are published and they're like half hour or 45 minutes long. so you can learn at your own pace, and the videos are in smaller chunks so that you can also process the information. Okay, and then it will help you to attend the live discussions. So try to answer this question. I hope that most of you will answer it. So what exactly is E here? Is it electron charge, current, voltage, or charge density? Your 1 minute is over now. So obviously the correct answer is voltage. So if you remember, I'm gonna discuss it here. So basically delta G is equals to N minus NFE. It relates the change in Gibbs free energy, that is delta G, to the electrical work done in an electrochemical reaction. It is commonly used in electrochemistry to calculate the free energy change of redox reactions. The terms in the equation are delta G, that is change in Gibbs free energy. It is measured in joules. So it determines whether the reaction is spontaneous or not spontaneous. If the reaction is spontaneous, the delta G will be negative. Second is the N. So N is the number of moles of electrons transferred in the reaction. So for example, in this particular reaction where copper is being reduced because it is receiving electron, the N, the net transfer of electron, is 2. F is Faraday's constant, and the value of Faraday's constant is 96,485 coulomb per mole. So it basically represents the charge of 1 mole of electrons. So 1 mole of electrons will contain Avogadro number of entities, and those number of entities will have this amount of charge. Okay, now you can see how we are relating to different constants to microscopic quantities. Okay, cell potential, where E, that was the question, E is a cell potential or electromotive force of the electrochemical cell in volts, that is V. Okay, so calculated under standard or non-standard conditions using the Nernst equation. Okay, this was the basic of delta G is equals to minus NFE. So what are the applications of this particular equation? So electrochemical cells, so in electrochemical cells it is used to predict the energy output of batteries and fuel cells. Thermodynamics, it links electrochemical and thermodynamic properties because delta G. Biological system, it applies to redox reaction in cellular respiration and photosynthesis. Okay, coming to the next question for today, what this question is asking, what is the definition of oxidation? Is it gain of the electron or the addition of oxygen? Is it loss of an electron or the addition of hydrogen? Or is it loss of electrons and the addition of oxygen? Or is it loss of electrons and loss of oxygen? So I am reiterating this multiple times, and I really hope that you guys will answer this question. Still, I'll give you guys 1 minute to answer this question. Go through each and every option carefully and what it means. Not only the right answer, you need to also ponder upon why the other options are wrong and what that particular situation will be called. Okay, so think thoroughly and try to answer. So did you guys do it? No. Okay, no problem. over try to answer this question. I know most of you guys will give the correct answer only. Okay, so your time's up. The right answer is obviously loss of electrons and the addition of oxygen. So the oxidation reaction is a chemical reaction in which a substance loses electron and increases its oxidation state. It is one half of a redox, that is reduction and oxidation process, where oxidation is always paired and paired with reduction. Okay, so we'll see in more detail what exactly is oxidation and reduction. Why we are focusing too much on it? Because this is the basis of electrochemistry. Okay, so let me just skip this ad. Yeah, I can. I hope
The chemical reactions taking place around us are some form of oxidation and reduction reactions. So what are oxidation and reduction reactions, and where do we find them? In the 1700s, the word oxidation originally meant a reaction with oxygen, where oxygen was added to a compound. This was because oxygen was the first known oxidizing agent. However, the definition of oxidation has become more general these days, including other types of reactions. In modern chemistry, oxidation means the loss of electrons during a reaction, and it doesn't necessarily involve oxygen. The opposite process of oxidation is called a reduction. The word reduction originally meant removal of oxygen, but in modern chemistry, once again, it means gain of electrons during a reaction. In a chemical reaction, one species loses electrons as the other species gains electrons. Therefore, oxidation and reduction reactions take place altogether. That's why oxidation-reduction reactions are simply referred to as redox reactions. Oxidation? Reduction? Electrons? What? Are you confused? Let's just remember the acronym LEO the lion, GER. What this stands for is loss of electrons is oxidation and gain of electrons is reduction. Or you can remember it as oil rig, which stands for oxidation is loss, reduction is gain. That is loss and gain of electrons, of course. Now, where do we find oxidation and reduction reactions in everyday life? Number 5. Combustion. Burning wood in the fireplace, burning coal, fireworks, lighting a matchstick. These are typical examples of combustion. Combustion is a redox reaction where a compound being burnt is oxidized and oxygen in the air is reduced. Combustion reaction is also used to fuel the space shuttle. The fuel tank of the space shuttle contains super cold liquid hydrogen and liquid oxygen in separate compartments. When they are mixed and burnt, they form water and release enormous amounts of energy. Talking about space shuttles, do you know what happened to the Space Shuttle Challenger? It was in January 1986, the Space Shuttle Challenger broke apart 73 seconds after launch, killing all 7 crew members. Well, what caused this disaster? One investigation concluded that due to an unusually cold weather that morning, a rubber seal in the shuttle's booster rackets became stiff. This allowed superheated gas to escape and burn through the external tank. The external tank collapsed, spilling liquid hydrogen and oxygen inside. As you can imagine, mixing liquid hydrogen and oxygen created the huge fireball. This was a combustion reaction horribly gone wrong. Number 4. Corrosion. Another classical example of oxidation is corrosion. Corrosion is a process where metals are eaten up gradually by the oxygen in the air. In a way, corrosion is a very slow combustion. Most metals react with oxygen to form oxides. The oxide of iron is commonly known as rust. In this reaction, oxygen gets reduced while iron gets oxidized. Number 3. Photosynthesis. Photosynthesis is the most common everyday chemical reaction. It takes place in the green leaves of the plants to convert water and carbon dioxide into glucose and oxygen. The plants use glucose as fuel or food, We breathe oxygen that the plants release into the air, and in this reaction, water is oxidized and carbon dioxide is reduced. Number 2. Battery. From flashlights to mobile phones, batteries are indispensable in everyday life. Batteries have 2 electrodes and an electrolyte in between them. Alkaline batteries such as Duracell uses zinc as the anode and manganese dioxide as the cathode. When you switch your flashlight on, zinc gives up 2 of its electrons, leaving zinc ions behind at the anode. It is an oxidation reaction. The electrons pass through the flashlight, turning the lights on. Then they re-enter the battery at the cathode. These electrons combine with manganese dioxide to form manganese oxide. It is a reduction reaction. To carry back electrons from the cathode to the anode inside the battery, charged ions flow through an electrolyte solution between the electrodes. This completes the circuit and powers your flashlight. Number 1. Digestion. Digestion? Who would have thought? Well, food molecules such as glucose, for example, react with oxygen in the body and break down into carbon dioxide and water. Energy is released in this process, which keeps us alive and grow. This oxygen-glucose reaction is slow at ambient temperatures outside the living cell, but it happens fast in the body with the help of enzymes. Well, that's it for today. If you learned something new today, give this video a like, share it with your
Correct? So these were the basic examples of redox reaction which we are using daily almost in our lives, right? Oh my god, why is this happening? 1 minute. Yeah, I'm sorry for that again. Okay, yeah. Coming to the next question for today. So what is the atomic number of iron and sulfur is? This and this respectively. So what you need to tell me is the atomic number of iron and sulfur. Okay, is it 26 16, that is 26 is for iron and 16 for sulfur, or is it 16 for iron and 26 for sulfur, or is it 26 for iron and 32 for sulfur? Is it 32 for iron and 26 for sulfur? As it's a pretty easy question, I'm gonna give you guys 45 seconds to answer this question. And your time starts now. And your time stops now. So the correct answer is 26 and 16. If you guys don't remember, this is the periodic table. So about iron and sulfur, as you can see, sulfur is here with 16. Correct? So if you remember the periodic table, this becomes easy. But if not, then obviously these are some basic questions that they might ask, because these are some important elements for which the electrochemistry is based, or basic reduction reactions are done. Okay, so if we look here, here is the iron and here is the sulfur. These are some basic elements, so you can just remember where they are and then you can guess what is the atomic number somehow. Okay, so the next question for today is, what is the value of Faraday's constant? We just discussed in the previous slides that what exactly is Faraday's constant and what is its value. So if you guys are paying attention, you will be able to answer this. Okay, so what is the value of Faraday's constant? So the first option is 96485.332 coulomb per mole, or is it 9648.533 coulomb per mole, or is it 964.855 coulomb per mole, or is it 9.6485 coulomb per mole? So I'll give you guys 1 minute to answer this question, and your time starts now. Try to answer this in the chat box. Let me check. And the time is about to be up. You, for constants, there is no trick. You have to remember their values because they are constant, and we can use these values to find out the things which we need to calculate. So Avogadro number was a constant, Faraday's is a constant. Okay, so you need to keep these values in your head. Well, your time is up. The correct answer, I hope most of you know, is 96485.33 coulomb per mole. And as you know, what is Faraday's constant? The Faraday constant is the total electric charge carried by 1 mole of electrons. It is a fundamental physical constant in electrochemistry and is used to relate the quantity of electric charge to the amount of substance involved in an electrochemical reaction. Its value is 96,485 coulomb per mole, where C is the coulomb and mole, it represents 6.022 into 10 to the power 23 particles. As you know, right? This is how we relate things and the constants. So with this one single constant, what we know, that this is the charge on these many particles, and these many particles comprises 1 mole. Okay. Now coming to the next question for today. So multiplying a half reaction by any number does not change the value of, is it enthalpy, entropy, bond energy, or standard reduction potential? I'll give you guys 1 minute for this question because you need to think about all these options, what they signify, what they are, and also the correct answer. Okay, and your time starts now. Your time is about to be over. Feel free to enter in the chat box what is the right answer and also the what other options signify. So time is up. The right answer is standard reduction potential. So what is standard reduction potential? The standard reduction potential is a measure of the tendency of a chemical species to gain electrons and be reduced under standard conditions, that is 25 degrees Celsius temperature, 1 molar concentration of solution, and 1 atm pressure for gases. It is expressed in volts and provides insight into the relative strength of oxidizing agents. What are the key concepts associated with standard reduction potential? Because this particular topic was not discussed in this week lecture. Okay, so I'm going a little bit deeper into it. So a reduction reaction is when a species gains electrons. The standard reduction potential measures this ability. Standard conditions refer to temperature at 25 degrees Celsius, pressure at 1 atm for gases, concentration 1 molar for solutions. These conditions allow for consistent comparison of reduction potentials across different reactions. So what are the reference electrodes? The standard hydrogen electrode, or SHE, is defined as 0 volt 0 volt and is used as a reference for all other reduction potential. Excuse me. The standard hydrogen electrode consists of a platinum electrode in contact with 1 molar hydrogen ions and hydrogen gas at 1 atm. This is the standard reduction potential of some of the common metals which are used in the electrochemistry or in cells or in basic redox reactions. Okay, so the standard reduction potential of copper is plus 3.4 volts. For zinc is minus 0.6 volts. For chlorine it's 1.36 volts. For iron it's plus 0.77 volts. Okay, those were some basic numbers. So you don't need to remember all these, but just remember which one has higher reduction potential, which one has lower reduction potential. Why we should know this information? Because as I've told you earlier, if you want to make an galvanic cell more effective, the higher the difference between the potential between the two electrodes, more effective that cell will be, right? So if you know the reduction potentials, you can merge elements or metals in such a way that there is a difference between their reduction potentials. Okay, so the next question for today is the choice of electrode material and surface preparation method are usually dictated by the suitability of the electrode for first, observing an electrochemical parameter such as heterogeneous electron transfer rate, observing an electrochemical parameter such as surface coverage, observing an electrochemical parameter such as redox potential, or all of the above. I'll give you guys 1 minute for this question because this is a little subjective and more understanding question. Feel free to answer, like give your answer in the chat box, or you can unmute yourself and give me the answer after the time is up. And your time, okay, I'll start. Okay, it starts now. Your time is up, and I really hope that you guys gave the correct answer. Well, the right answer is all of the above. So why we need to look for all these parameters while choosing the electrode? So that the cell can be more effective, right, and more efficient at the end of the day. Coming to the next question. So okay, this question is asking blank was awarded the 2019 Nobel Prize in Chemistry with this and M. Stanley Whittingham for the development of lithium ion batteries. Okay, this is pretty recent, you guys should know whether the blank names are Yoshino or Goodenough, Miller or Goodenough, Yoshino and Miller, or Nurst or Miller. So I'll give you guys 30 seconds because this is again a memory based question. So your time starts now. Please drop your answers in the chat box. You need to be active in the class, otherwise you won't understand anything or you won't learn anything. Best way to learn is follow this week's lecture, come to the live discussions, ask your queries, and then solve previous year questions. This will definitely help you in gaining more from the subject and will ultimately lead you to perform better in the exams. Okay, so your time is up for this particular question. Well, the correct answer is Yoshino and Goodenough. So we should know why recent Nobel Prize is given to lithium ion batteries, right? What exactly they provide us. So for this, we'll have this a particular understanding of lithium ion batteries and the Nobel Prize. I hope you guys can hear it.
The Chemistry Prize of 2019 has been awarded to 3 persons. It's John B. Goodenough, it's M. Stanley Whittingham, and it's Akira Yoshino for their development of the lithium-ion battery. The story of the lithium-ion battery starts in the 1970s when Stanley and Whittingham started using lithium in the batteries, and this gave a really powerful battery. And then John B. Goodenough realized that he could replace the cathode material that was used by Whittingham, and he actually increased the capacity of the battery by the double. At this point, the batteries relied on lithium metal, which is a very reactive compound, and the contribution of Akira Yoshino was to replace the lithium metal with a carbon-based material and thereby increase the safety for the lithium-ion batteries. The benefit of lithium-ion batteries, we can see it every day. We use lithium-ion batteries in our cell phones, we use it in our laptops, and we use it more and more in electric vehicles. And for the future, we hope that even better lithium-ion batteries can be used to store energy from renewable sources, such as wind and solar, because the wind doesn't always blow and the sun doesn't always shine, which means that we want to store the energy from, we want to store the renewable energy in lithium-ion batteries so we can use it when we need it the most. In turn, this will decrease the use of fossil fuels and thereby decrease the amount of greenhouse gases that we emit. For the future, the lithium-ion batteries hold even more dense batteries with more energy per volume and weight. And we can also see that the science and the knowledge that these 3 laureates have contributed with can open up for even newer battery systems relying on perhaps different ions or different materials that will perhaps give cheaper, better and more environmentally friendly batteries.
This is the advancement and the usage of batteries. Okay. Oh, so well, this ends our discussion for today. Let's summarize whatever we have discussed in this session. Let me quickly summarize. So we discussed about what is bioelectrochemistry. So bioelectrochemistry is an interdisciplinary field that combines principles of biology and electrochemistry to study the interactions between electrical processes and biological systems. It focuses on understanding how biological molecules, cells, and tissues interact with electrical signals or undergo electrochemical reactions. This field has significant applications in medicine, biotechnology, and environmental sciences. So basic areas where biochemistry is used is electron transfer in biological system, biosensors, electrochemical techniques, bioelectronics, electrochemical energy conservation, electroporation, bioelectrochemical system for environmental applications. Then we delve more into the applications of bioelectrochemistry, which were medical diagnostics, therapeutics, energy production, environmental sciences, and many more. And then we delve into the basic building block of electrochemistry, that is the reaction or the redox reaction. So what a redox reaction is, short for reduction and oxidation reaction, is a chemical reaction in which electrons are transferred between 2 substances leading to changes in their oxidation states. It involves 2 simultaneous processes, that is oxidation and reduction. Then we see what are the key features of redox reaction. So there are electron transfer, coupled processes, and there is an association of change in oxidation states. Then we saw some of the examples of redox reactions. Then we went to the applications of redox reactions, which included energy production, metabolism, corrosion and protection, and environmental chemistry. Then we delve into the galvanic cell, that is the instrument or a cell which is based upon the basic building unit, that is the redox reaction. So a galvanic cell, also called a voltaic cell, is an electrochemical cell that generates electrical energy through a spontaneous redox reaction. It consists of two half cells connected by a salt bridge, a porous membrane, and an external circuit that allows electrons to flow. So the components of galvanic cells were two electrodes, electrolytic solution, salt bridge, or a porous barrier, or at the end an external circuit. Then we saw how a galvanic cell works. Basically, anode is there, cathode is there, electron flow is associated with it, and to maintain the flow there is salt bridge. Then we saw the example of a basic galvanic cell, which is made up of zinc as an anode and copper as a cathode. Then we discuss some of the characteristics of a galvanic cell, which includes electromotive force, spontaneous reaction, and further the applications of the galvanic cell. Then we discussed questions, obviously, right? So with this, I'll complete my today's lecture, and I'll see you guys in the next week. I hope that you guys will be following this week's lecture as well as the next week's lecture. When you go through the lecture and then you come to the live discussions, it becomes easier for me as well as for you to follow the subject, and I can clear your doubts as and when they come. Okay, so please go through the lectures and then attend the live discussions. The exam will be super easy for you if you just follow these simple steps. Okay, and I hope that you guys earn certificate of bioelectrochemistry, and this is a fundamental of biochemistry. There are too many things in this particular course, but for a 4-week course we'll just cover the basics and grounds of it, so that you know what exactly biochemistry is, and then with your further interest you can enhance your knowledge and explore based upon whatever you feel like is okay for you, right? If you have any problems, any questions, feel free to reach out to me. I'll clear your doubts, and we can discuss topics also if you were not able to get in the lecture. Okay, so yeah, all the best, and see you all next Saturday, same time. Okay, thank you so much.